ladies, I'm going to give you some notes on a couple of short topics that are connected to applications of derivatives. So the first one we're going to talk about is vertical motion. This is an idea that simply moves one-dimensionally up and down, like dropping a ball or throwing a ball straight up in the air, not at an angle, or sometimes we'll talk about a particle moving up along the X or Y axis. So when you're talking about motion, you're going to be given some information about the position of an object. For some reason, in math, we have decided to call position S. I'm sure there's a really good reason for that. I don't know what it is. And this is a basic format for the position of an object with respect to time. In this case, S is position, and I'm going to give it in feet. And T is in seconds. Okay. The two subscripted variables here, V sub 0 stands for the initial velocity, and S sub 0 stands for the initial position. Some people use V sub I and S sub I for that, okay? But I'm going to use this as 0, meaning at the beginning at time 0, okay? All right, so that's position. And then you've got velocity, which is the change in position over the change in time. Okay. And at this point, you have worked mostly with average velocity, which just tells you what the object's position is over an average. Like if you drive from here to DC and you drive 120 miles and it takes you 2 hours, your average velocity is 60 miles per hour, although you actually travel at many, many, many different speeds during that 2-hour time period. Okay, so that's your average velocity. All right, we are now going to look at instantaneous velocity. Okay, and we will designate that with V. And it is equal to the derivative of position, the rate of change of position. How does position change? That's velocity. So if we go back up and look at that original position formula that I gave you, you get negative 32t plus v sub 0. The units on velocity will be the units of position, which was feet, divided by the units of time, which was seconds. So this velocity will be in feet per second. Okay? And the third piece of information is acceleration. Acceleration is how velocity changes, change in velocity over the change in time. And if you just take those actual changes, you're going to have an average velocity. But I want to look at the instantaneous velocity. The instantaneous acceleration. And again, acceleration is how does velocity change with respect to time. And so we have our acceleration function, which is the derivative of the velocity function. So if we go back up and look at our velocity function and take its derivative, we get that the acceleration is negative 32. And the units of that are the units of velocity, feet per second, over the units of time, which is second. And we usually call that feet per second squared. You may recognize remember from physics that you often did acceleration was meters per second squared. That was just working in the metric system. This is working in the English system. This number right here for things falling through the air, this is the acceleration due to gravity in feet per second squared. Okay? So you get the same three set of equations in the metric system with different values, okay? So these should look fairly familiar, at least the constant should feel familiar to you. The only difference here is you've got a different value right here. This is in, time is still in seconds, but this time position is in meters, okay? So once again, again, velocity, instantaneous velocity is the derivative of position, and that gives us negative 9.8 t plus initial velocity. And acceleration is the derivative of velocity, and that gives us negative 9.8, or 9.80 is what you probably use in physics. And this again is the acceleration due to gravity. This one is in meters per second, which we call meters per second squared. Okay, these are some things that you use in physics. I'm sure this is negative 9.80. All right. So, how are you going to see this in calculus? Well, let's just look at a couple of possible scenarios. An object is dropped from a height of 40 feet. Okay? An object is dropped from a height of 40 feet. So I'm not going to answer a question right now. I just want to see what information is given in this problem. First of all, you're working in the English system, so you're going to want to start with that position function that is the negative 16 in it, not the negative 4.9. And that's because you see the feet here. Okay? The second thing, you're told it is dropped, and that tells you that the initial velocity is 0. You're just letting it go, starting out at rest. And then you've got the initial height here of 40. So from this information, you can tell me that the position function for this object is negative 16t squared plus 0t plus 40. And from there, you can get me velocity, which is the derivative, negative 32t. And you can take me to acceleration, which for these problems is that constant, negative 32. Okay? Second possibility, an object is shot up from the ground at 150 meters per second. Okay? So what all information is in here? Well, first of all, you're in the metric system here, so you're going to use that formula with the negative 4.9, not the negative 16. All right? Second, it starts on the ground. So by convention, we're going to say that the ground is position 0 unless you're told otherwise. You can make anything position 0, but if you're ever just reading a word problem in physics or in math, and the word the ground is there or sea level is there, those are generally taken as 0. Okay, so there is our initial position is 0, and this value right here is our initial velocity. It's shot upward, so it is positive. All right. So I can take those same 3 formulas, use them with the metric, make that a little bit lower. Right, and then you can get your formulas for velocity and for acceleration. Okay, the third situation, an object is thrown down from the top of a 300-foot building at 25 feet per second. Okay. All right, so we're in feet again, so we're going to use the one with the 16, not the 4.9. All right. So there's 2 pieces of information here that are important. One, it's thrown down, and they give you the speed here. The fact that it's thrown down, and they give you a speed of 25, you have to take that as an initial velocity of negative 25, because it starts out moving down. So things that are moving up have a positive velocity, things that are moving down to negative velocity. And the second one, it starts at the top of the 300-foot building, so our initial position is 300 feet. Right? And I'm just going to write the first equation this time. Your position equation would be the negative 16 because we're in feet. No, not plus, minus 25t and plus 300. Okay? So you're going to read a problem and you'll pull out the given information and write your position function, write your velocity function, and your acceleration is either going to be for these gravity problems, it's either going to be negative 32 or it's going to be negative 9.89. All right? So then you're going to be asked to find something. All right? I'm going to actually work with you these, but I'm going to remind you of what they're telling you in the question. So find the position at t equals 2. All right? So if I ask you to find the position at 2 seconds or at t equals 2, then you're going to write on your paper s of 2, and then you're going to find s of 2. Okay? If I ask you to find the velocity at 4 seconds, then you're going to write on your paper, find the velocity at 4, and use whatever equation is appropriate. Okay? If I ask you to find the average velocity from 2 seconds to 4 seconds, this is different. This is average velocity. You don't take a derivative to find average velocity. Instead, you go back to that first one, change in position over change in time. Okay? So the change in position over change in time would be find the position at time 4 and find the position at time 2 and subtract. And then subtract 4 minus 2. You know that that's just slope. That's y2 minus y1 over x2 minus x1. This is on average what's the velocity, not what was the velocity at any specific time. Okay? If I ask you to find the time required to hit the ground, time required to hit the ground. Remember, ground level is position equals 0. So you're going to write down the position function. You're going to set it equal to 0, and then you're going to solve it. The time required to reach a height of 10 meters or feet or whatever you're working in. Well, once again, I'm going to get a height of 10 meters. I take the position function, I set it equal to 10, and then I solve it. Okay? Solve it, figure out what t is. All right? If I ask you to find the velocity, if it just says velocity, it means instantaneous velocity, so that's v, not average velocity. So that's that v equation, the s prime. Find the velocity when it hits the ground. Okay. Well, the first thing, you have to figure out when it hits the ground. So you're going to take the position function and set it equal to 0, and you're going to solve for t, some specific value of t. So I'm going to say t equals 10. Some specific number. You're going to get that number, and then you're going to take the velocity and plug in that value. All right? So sometimes you got a little bit of a two-step thing going on. Okay? If I ask you to find the initial height of an object if, okay, let me find the initial height of a dropped object. If it hits the ground at t equals 5. two things happening here. I've given you some information, but I haven't given you all of it. All right, you obviously are looking for S of 0. That's the initial height. You've got this function, S of t equals, I would need to know if I'm working in meters or in feet, and we'll come back to that later. So S of t, we know S of 5 has got to equal 0 because in 5 seconds it hits the ground. So you're going to set up your function, okay, with S of t. I'll just use the 16, negative 16t squared, okay, or it would be negative 4.9 if you were working in meters. And you need the initial velocity. Well, the initial velocity is given in the question. The object is dropped. That means the initial velocity is 0. And you do not know this. You set that up and set it equal to, so S of 5 would be negative 16 times 5 squared plus S of 0. My 5's and my S's look alike. That's dangerous. And then set that equal to the ground, and you would be able to solve for S of 0. So a lot of this is about translating what is the information that's been given to me, and how can I use that along with these 3 set equations to figure out what I'm looking for. Okay? All right, there's a secondary piece that comes into this that I need to make sure you're aware of. And this is true for all linear motion, okay? For linear motion. Anything that's moving in one dimension, straight up and down, completely left and right. Those are the 2 most typical things. So, 1, the sign of the velocity. Okay? If the velocity is positive, then we consider it moving either up or right, depending on whether you're doing vertical motion or horizontal motion. If the velocity is negative, then it is moving either down or left. And if the velocity is 0, it's not moving. It is stopped. So if you're ever asked a question that asks you when something stops, that means you set the velocity equal to 0. Okay? The sign of the acceleration. This one is a little bit less intuitive. Okay? If the acceleration is positive, that means that the force is positive. I know y'all remember that from your physics. Force is positive. Okay? And that means that the force is pulling it up, pulling has 2 L's in it, or left. I mean, up or right. Okay? So something is pulling it up or to the right. If the acceleration is negative, that means the force is negative. And that means the force is pulling it down, like gravity, or left. And if the acceleration is 0, then their force is 0, and that means it's not, there's no net force acting on it, so that means velocity is constant. It doesn't mean it's not moving, it just means the velocity is not changing. Velocity is constant. Okay? All right, I'm going to add to that 2 pieces of information. If the velocity is positive and the acceleration is positive, both of them are the same. This tells us that it is moving right or up, and being pulled to the right at the same time. So if you're already moving to the right and then something pulls you, what's going to happen? You're going to speed up. Okay? You're going to speed up. If your velocity is negative and your acceleration is also negative, then you are moving to the left or down, and something is pulling you to the left. If you're already moving to the left and something pulls you to the left, you're going to speed up. So what you can get from this is if velocity and acceleration have the same sign, the object is going to go faster. It's going to speed up. Okay? It's going to speed up. Now, the counter to that, if the velocity is positive and the acceleration is negative, and you are moving to the right or up, as you try to move to the right, something pulls you to the left. If you are trying to move right and something pulls you to the left, you are going to slow down. If the velocity is negative and the acceleration is positive, then you are moving left, but something pulls you to the right. If you try to move to the left and something pulls you to the right, you are going to slow down. So those two things combine to tell you that if velocity and acceleration have opposite signs, then the object will slow down. Okay, so that gives you enough information to get started on the velocity and acceleration portion of this. I'm going to stop and load this video separately and load the second one with the rest of the information as a separate video.